Assalamualaikum and good day everyone. So in this third video, we will learn equation of motion, general plane motion. Okay. Chapter 5. Okay, when a rigid body is subjected to external forces and coupled moments, it can undergo both translational motion and rotation motion. This combination is called general plane motion. Okay, as you can see in the figure. Next, using an XY internal coordinate system, the scalar equation of motion about the center of mass G may be written as summation of Fx equal to MAGX, summation of Fy equal to MAGY. Okay, next at point G, so look at G, summation of moment at G equal to IG alpha. Okay, and look at point P, summation of moment at point P equal to summation of MKP. Okay, so MKP represent the sum of the moment of IG, A and MAG about point P. Okay, by using parallel theorem. Okay, next. Consequently, we can write the three equations of motion for general plane motion of the body as first, Fx, summation of Fx equal to MAGX. Next, summation of Fy equal to MAGY. Summation of moment at G equal to IG alpha. And summation of moment at O, okay, point O can be at any point other than point G, equal to IO alpha, where IO equal to IG plus MRG square. Next, okay, in general plane motion, we have two conditions: rolling without slipping or rolling with slipping. Okay. Rolling without slipping is only applied on disc or wheel, etc. Okay, first let's see rolling without slipping. Okay, so to find velocity at any point on a rolling object. So first, velocity at point in pure rotation. Okay. In center of mass reference frame, so we know that Vt equal to R omega. Okay, and as you can see from the figure, it rotates clockwise. Okay, and next, velocity at point in pure translation. Okay, relative to ground, so Vt tangent, okay, equal to VCM. At ground also, VCM equal to Vt but in negative sign. Okay, and equal to velocity at point in combined rolling motion relative to the ground, so 2 VCM. Okay, and at center VCM, and zero velocity at the ground. Okay, next, frictional rolling problems. When analyzing the rolling motion of wheel, cylinder or disc, it may not be known if the body rolls without slipping or if it slips or slides as it rolls. Okay. So for example, consider a disc with mass m and radius r. subjected to a known force P. Okay, like in the figure. And next, the equation of motion will be summation of Fx equal to magx, okay, equal to P minus F. So F is the friction force equal to mag. Okay, and for y-axis, summation of Fy equal to magy. So we know that magy is equal to 0, and normal force minus mg equal to 0. Okay, next one more equation is moment. So moment at G equal to Ig alpha. So we have friction force times R equal to Ig A. Okay, so there are 4 unknowns, F, N, alpha, and Ag in this 3 equation. Hence, we have to make an assumption to provide another equation. Okay, because we don't have enough equation to solve these 4 unknowns. So we have to make an assumption to provide another equation. Then we can solve for the unknowns. Right? The fourth equation can be obtained from the slip or non-slip condition of the disc. Okay, so for case 1, assume no slipping and use Ag equal to alpha R as the fourth equation, and do not use Ff equal to mu Sn. Okay. After solving, you really need to verify that the assumption was correct by checking if Fn less or equal to mu Sn. Okay. And case 2, assume slipping and use Ff equal to mu Kn as the fourth equation. So in this case, Ag is not equal to alpha R. Okay. So this is the important part, because you need to assume whether the disc is slipping or not slipping. Okay. So assumption 1, no slipping, and assumption 2, slipping. So for acceleration, when no slipping, Ag equal to alpha R. Okay, if slip, Ag not equal to alpha R. Okay, and for friction, when you assume no slipping, you can not use Ff equal to mu Sn. Okay, and for slipping, Ff is equal to mu Kn. Okay, for assumption 1, you need to verify that the assumption was correct by checking if Ff is less or equal to mu Sn. Okay. Next, procedure for analysis. Okay, so the important part, procedure, how to solve the problem. Problems involving the kinetics of a rigid body undergoing a general plane motion can be solved using the following procedure. Okay, first, establish the XY internal coordinate system. Draw both the free body diagram and kinetic diagram for the body. Okay. Specify the direction and sense of the acceleration of the mass center Ag and the angular acceleration alpha of the body. If necessary, compute the body mass moment of inertia Ig. Okay, next, if the moment equation summation of MP equal to summation of MKP is used, Use the kinetic diagram to help visualize the moment developed by the component MAGX, MAGY, and IGA. After that, apply the three equations of motion. Next, identify the unknowns. If necessary, there are 4 unknowns. Make your slip or non-slip assumption. Okay. Typically, assume no slipping or use of AG equal to AR is assumed first. Okay, next. Use kinematic equation as necessary to complete the solution. If a slip, non-slip assumption was made, check its validity. Okay, key points to consider. Be consistent in using the assumed direction. Okay, the direction of AG must be consistent with A. Right? If F equal to mu Kn is used, FF must oppose the motion. As a test, assume no friction and observe the resulting motion. Okay, this may help visualize the correct direction of FF. Let's see example. Okay, so example 3. Okay, the spool has a mass of 100 kg and a radius of gyration of kg equal to 0.3. Okay, so radius of gyration is kg. If the coefficient static and kinetic friction at A are mu s equal to 0.2 and mu k equal to 0.15 respectively, determine the angular acceleration of the spool of P equal to 50 Newton. Okay. So first thing first, you need to draw free body diagram. Okay. So normal force, and then friction force, P, and weight. Okay. Next, kinetic diagram. Okay, so as you can see, P is pull. So alpha will move and rotate clockwise. Okay. And the spool also will move in translation motion to the left. Okay, next, apply equation of motion. Okay, first, summation of Fx equal to MAGX. So 50 plus FA, okay, friction force, equal to MAG, M100 and AG. Okay. Next, summation of force at Y axis. So NA minus 100 times 9.81 equal to 0. Okay, so NA minus 100 times 9.81 equal to 0. So you get NA equal to 981. Newton. Third equation is for moment. So assume clockwise is positive. Okay, so the moment is 50 times 0.25. Okay, 50 times 0.25 minus, okay, positive because P is rotating clockwise, and the other force is FA. So FA is rotating counterclockwise, so will be negative FA times 0.4. Okay, so here negative FA times 0.4 equal to IG alpha. Okay, so IG for this is M. Oh, sorry, the question here give radius of gyration. So use formula of radius of gyration. Okay, so M K square alpha. Okay, so question number 2. Next, assume no slipping motion. So when no slipping, AG equal to 0.4 alpha, which is R. Okay, so R alpha. Next, solve the unknown. Okay, please try by yourself and solve the unknown, you get the answer. Next, remember you need to prove the analysis is non-slipping, so you need to compare between FA and mu SN. Okay, so when you compare, FA is larger than mu SN, so it proves it is non-slipping. Okay, so this is the final answer. Okay, next for example 4, I need you all to do by yourself first, and we will discuss this example in the next class. Okay, good luck. Thank you for watching. Assalamualaikum.